Director of Instructional Services for Farmington Public Schools. I have two very important people with me. Maurice Merrigan, she is one of our math coordinators. This is Eric Newton, he is our other math coordinator. In the back of the room, turn around and wave at them. Hello, there are teachers. There are a whole bunch of them I want to introduce, and there's one over the side, and you're going to be spending some time with them tonight as well. And we'll introduce them when it's time to go, because they're going to help us as well. Tonight is a parent forum on bridges in mathematics. Here is what we're going to do tonight, our objectives, as we like to say in edu-speak. We're going to talk about the 4 key ideas in Bridges. Bridges distinguishes itself from other math instructional resources in 4 big ways. And that's going to be the emphasis of the first 20 minutes of the presentation. Maria and Eric are going to take you through those 4 big ideas in Bridges. Next, you're going to go off with the teachers. You're going to get to pick a grade level, K through 5. And you're going to get a chance to see a sort of a slimmed down version of a Bridges lesson. They're going to go a little bit faster. Well, I think a little bit faster, right? Yeah, than they normally would.
Probably ask them. No?
You guys going to go faster, you're going to slow it down. Slow it down a little bit, right? Okay. So after you do that, and then the purpose behind that is that you actually get to see and feel and hear the kinds of experiences that your students are having on a daily basis in our classrooms when working with the Bridges instructional resource. Finally, for those of you who want to come back, we're going to have questions and answers. The way we do questions and answers in forums like this is there are little, and I think they're blue, right? I'm colorblind, so it's a guess, it's a toss-up for me. They're blue. And on the back table are blue sheets. And on those blue sheets, thank you very much, you can write your questions. And what we'd like you to do is then write the questions before you go out to the lesson, okay? Or perhaps as you come back in, you give them to us, and then we'll try to answer them for those who want to stay. That's an optional part. You don't have to stay if you don't want to. The other thing that we have for you is there is a page of 2 or 3 questions and commonly asked questions and answers. Those are ones that we've collected from doing this in the past. If your please check and make sure that we didn't already answer your question, or you might get the information you need right there, right now. Did I say that right, guys? Did I get that?
In addition, in the white packet, the very last page is a directions sheet on how to use the Math Learning Center website, and the Math Learning Center is the publisher for the Bridges resource that we're using. So it takes you through some key components of that website in case you're interested in navigating through that.
It is an excellent website. It contains links to what I would call applets or games and things that your children can use that bust them up by grade levels. It also has lots of background information. My daughter is a 6th grader. We did Bridges last year as a 5th grader, and in my home we use that website frequently. A couple things, I want to make one quick point. You're going to hear us use the phrase instructional resource. Sometimes people say Bridges is the curriculum. The curriculum is a set of standards that we want our students to know, do, and apply. It is directed right now by the state of Michigan. In the next couple of years, we're going to change that to the Common Core standards. There's a new initiative nationally that's coming forth, and that is our curriculum. Bridges is a resource that we use to teach the curriculum. So Bridges has to be aligned to teaching the outcomes. I just want to make that little clarification in case you hear me not refer to Bridges or them not to refer to Bridges as the curriculum. It's an instructional resource that we use to teach the curriculum. Bridges features whole group, small group, and independent activities. Many of our resources do. Bridges is very specific in prescribing the use of all 3 of these types of instructional groupings. You'll probably see that tonight. Lessons incorporate increasingly complex visual models. This is one of the big ideas in Bridges that we're going to talk about, the use of visual models. Seeing, touching, working with manipulatives and sketching ideas. Eric's going to talk more about this and how it's a little bit different than what we might have experienced in what we would consider a more traditional math classroom. Correct?
No, I am.
Okay, thank you. Maria's going to do it. Students are encouraged to explore, test, and justify their reasoning. This is a big part about what we want students to be able to do. They have to be able to explain how they came up with the answer they came up with. One of the questions that I get asked frequently, I think I'm done with this, is, well, what was wrong with the old way we used to teach math? You know, it worked for me. Why do we have to Why do we have to do something differently? I don't understand why you have a new instructional resource. I mean, isn't 2 plus 2 going to equal 4? Have you changed that in some way? I think a medical analogy is the best one to represent this. My grandfather, Seymour Cohn, had dental work done. He was born in 1917. He had dental work done all through his childhood. I, too, his grandson, get dental work. I prefer to have the techniques now that are used than Seymour had when he was a child. It doesn't mean that the dentist at the time did anything wrong. It simply means that my grandfather's experience with dentistry is likely not as positive as mine because we know more about medicine, we have better technology to use, and our practice has evolved. The field of education is constantly changing. Teaching and learning is constantly going to be revised and going to evolve. We need to continue to evolve with that. And always going back to that medical analogy, whether it's dentistry or cardiovascular medicine is another one that's a great one to talk about that. Keep that in mind as we talk about why these innovations are necessary. We know more about children, we know more about learning, and we know more about teaching than we ever have before.
All right, these are the 4 key features of bridges that John was referring to. There's inquiry-based, visual models, mathematical discourse, and this idea of spiraling concepts. And those are the 4 things that Marie and I are going to talk to you about in the next few minutes. The first one is this idea of being inquiry-based. And what is that? Well, that basically means it's allowing children to develop things or discover things on their own. Me, along with you, many times, or when we were taught in a different way than we teach now. Many of us were given what we call an algorithm, which is an algorithm is just a set of steps that you go through to solve a problem. And you were given that set of steps, and then you were asked to practice it with problems. And that's how I was taught in a lot of my classes, probably the way many of you were taught. What inquiry-based does is it doesn't just give the students the algorithm. What it does is it allows them to work out problems in the way that makes sense to them, and they do that continuously with multiple problems, and then they look for patterns and things that occurred throughout those problems, and then they develop the algorithm on their own instead of just being given the algorithm. They develop the set of steps to solve the problem on their own, and then they practice that with more problems. And that's really important because when you go through that process of discovering it yourself, it stays with you. You retain that. You're able to remember that a lot easier later on. That idea of going through that process is really helping to prepare students for the future for a lot of reasons. Because of the retention, and also because, like what John was saying, with the new Common Core and the way that our education is going, the direction we're going, this is only getting them more prepared for that in the future. This is just a diagram that kind of shows you what I was just talking about. The algorithm is just that set of steps that a lot of us were just given and told, okay, this is how it goes, you practice it. Whereas Bridges allows them to develop that on their own through doing problems and come up with that algorithm on their own. So it's not that the program doesn't use the same steps that we used when we were taught math. It just allows them to discover that on their own. And it has a lot more meaning that way.
One of the big ideas, or those key ideas of Bridges, is being able to use a visual model. And a visual model does not depend on language. A visual model is a picture so that students in their brain can see the mathematics that's happening. It's not just numbers. It's not just a word sentence like 2 plus 2 plus 2 equals, but it's actual pictures that students use and manipulate in order to have a better number sense, so that when you're talking about things, they can actually see it in their brain and not just try to recall those rules that we all learned by. So some examples that Bridges commonly uses, and this isn't all of them, but this is some of them, these are the major ones, are 10 frames, 100 charts. We're going to show you a sample of a number corner work from students. number lines as well as multiplication arrays. How many of you have ever heard of any of these? Excellent. All right, so here's a 10 frame. And in this particular example that I'm showing to you, they're using it to model addition, how students can use it to see how 7 plus 5 is 12, and you have a real visual model. You can see in the bottom that one of the 10 frames is filled, and you have 2 additional ones. In the hundreds grid, some of the ways in terms of building their numeracy is how many different ways can you represent 65? And you can use that 100 frame in a bunch of different ways. If you notice, a column is how many? 10. A row is how many? 10. The top fourth of that is how many? 25. So the kids can actually have those visual models and see how much is filled in without having to count one by one. So they can do skip counting by 10s, they can do skip counting by 5s. They can see half really easily, a quarter really easily. You can do fractions, you can do decimals. So these hundreds charts, or hundreds grids, are very useful. This is the example, and I know it's kind of dark, but basically what this is a first grade example of students showing what the number 30 is in many different ways. So they used tens frames, they used hundreds grids, they used coins, they used pictures of leaves, because this was in the fall, the 30th day of school. They used Unifix cubes, which is difficult to see, and then they also used their calendar grid that they use in Number Corner, which is a part of the bridges. So they spend time every day talking about how many different ways can we make 30. And that's an example of what they commonly do in their class. They use number lines, not just to order numbers and see which is larger or smaller than another, but also to do addition and subtraction. And this one is, well, I guess as a secondary person, is very powerful to me because this makes the connection between not just multiplication, but into quadratics, and when you're factoring quadratics. For those of you that are math, understand what I'm saying when I say quadratics. But that's the connection that we can make between what's happening in an elementary school to what's happening in the middle and in the high schools. How many of you are familiar with multiplication using arrays?
One of the other key features to the Bridges program is this idea of mathematical discourse. And what is that? Well, here we've got one definition of what mathematical discourse is, and that is a classroom culture where students make conjectures, talk, question, and agree or disagree about problems in order to discover important mathematical concepts. It's this idea of talking about what you're thinking and what you're doing, because what we know is that when students have an opportunity to talk about what they're thinking, while they're talking and explaining it to another student or the teacher, they're reconstructing that concept in their mind. And then when other students hear them talk, they're reconstructing it as well. And then students agree or disagree or talk about what somebody else said, they're reconstructing it in their mind again. So every time people begin to talk about this concept, they're reconstructing that in their mind, which only deepens and strengthens their understanding of that concept. So this idea of giving students a chance to talk about and explain their thinking and agree and disagree really deepens their understanding of that concept. And how does Bridges do this? Well, they do this in a few ways. One way is by asking open-ended questions. And an open-ended question basically means it's a problem that doesn't have just one answer. So instead of saying, okay, in a traditional way, what is 15 plus 5? Well, there's one answer there, 20. An open question would change it around a little bit and say, all right, give me two numbers whose sum is 20. You've now it's essentially the same concept, it's adding two numbers. But now you're opening it up to give students many, many different ways to add two numbers to get 20. Could be 10 and 10, 15 and 5, you could even get into things like fractions and decimals, all to get a sum that would be 20. And when you have all those different ways to do a problem, students start to talk about the way they did it. And they're telling somebody else, and then they're talking about how they did. And you get a big discussion going about this concept of adding. And all that talk is students reconstructing those ideas in their head, which just deepens and strengthens their understanding. The other thing that Bridges does a lot, if you look in the the materials that they do and the problems they're going to do, they're asked to justify their thinking all the time. Bridges is constantly asking students to explain your reasoning. Okay, I did a problem this way. Why? Explain what you did. Explain your thinking. Explain your reasoning. So that students don't just do a problem, they have to explain why they did it. And again, it's that talking about why they did it, it's reconstructing and rebuilding all that stuff in their mind while they're talking about it, and that just deepens their understanding of the concept.
The final key idea that we're going to talk to you about today is spiraling concepts. And spiraling is pretty self-explanatory. It's not doing it one time and done. It's seeing it and practicing it some, moving on to something else, moving on to something else, coming back to it, seeing it again, practicing it some more. So you're doing it over and over again throughout the year. And we know that none of us learn things, or most of us I should say, I'm not fortunate enough to learn things the first time and be done with it. That the more we see it, the more we remember it. And so that's one of the reasons why they spiral. In addition, when we learn things, or if we want to learn something, we have to connect that new knowledge to something that we already know. If we can't make a connection between what's being presented to us or what we're trying to learn and what we already know, we won't retain that new knowledge. We'll lose it. Whenever we learn, we have to attach it to something that we already have inside in order to retain it and be able to use it again in the future. In addition, we want to be able to take what we're learning and be able to use it in another situation. For example, when I go back to the visual model that I showed you, the hundreds grid. Students learn that, first of all, just to get number sense. How much is 65? Show me how many different ways that you can make it. How do you know that's 65? But then we can change it to percentages. Show me 65%. Same hundreds grid. So we're using that same visual model, but now we've switched from whole numbers to percentages. How do you know that's 65%? Prove to me that's 65%. Can you make it in a different way? Yours doesn't look the same as yours. Why is that? So that is another reason that we want to spiral. We want to continue to use those same things that are presented maybe in earlier grades or even earlier in the year and revisit them again in later grades so that these are familiar things to students. So it's not like, oh my gosh, this is something new. How do they expect me to learn all these new things? That we're making it less scary for them. Oh yeah, I remember doing that. And I could do that, so I could do this too. And like I said earlier, the more we do things over and over and over again, the more we're going to remember them. It's the same thing in a classroom. It's the same thing with Bridges. So we always want to be making sure that they're seeing these things over and over again. We don't want to present something in September, and then when it's on the assessment the following year, if we talk about me, and they're supposed to remember it, if we're not revisiting those things over and over again, it's going to be much harder for them to recall and to use what it is that we were teaching back in September. So the more we revisit it, the more likely they are to remember it and be able to apply it. This is not a key idea of the Bridges program, but it is something that we are getting many questions about. And I say that because when we talk about differentiating in an educational sense, it is not doing something different than what the other kids are doing. It's taking a big idea that we're teaching in the classroom, but teaching it at different levels. Allowing students access at whatever level they happen to be at, around that big idea. And those questions that we ask of the students afterwards could allow any student from any level to be able to answer those questions so that students can build upon each other's ideas regardless of what level of learning they're at. So there are two ways that we are working with teachers this year on. It comes from the National Council of Teachers of Mathematics. They are open questions, which Eric referred to earlier. He had given you example. Here's another example. The answer is 42. What's the question? Think about that just for a second. Anybody have an answer?
It's a Jeopardy
come on.
question.
6 times 7.
6 times 7.
What is?
Excellent.
What is 6 times 7?
What is?
That's right. What is it?
40 plus 2.
You better say what is
There we
it?
go. The meaning of the universe from the Hitchhiker's Guide. Anyone else have an answer? 40 plus 2. So we've hit multiplication, we've hit addition, we've hit trivia facts. You could have so many different kinds of answers that come from that particular question. In your own classroom, you could say that you want it to be a measurement. Maybe you're measuring something. It could be with fractions. It could be many different things, but you open it up so that students can enter into the problem from wherever they are comfortable entering into it. In addition, we've talked about parallel tasks. So I've given you an example of a parallel task up here as well. This would be from a geometry unit. You could have students choose two-dimensional shapes to create a creature. And this happens to be from kindergarten through 2nd grade, this particular task. Or you could have them choose a three-dimensional shape to create a two-dimensional creature, or any creatures. So, depending on where their comfort level is with working with shapes, they might want to stick with 2D. You know what, I'm not moving to this 3D, that's a little scary, I don't want to go there. But just having them be able to talk about the shapes they created, what shapes did you choose to make your creature? What makes this creature different than that creature? And you can ask those same questions regardless of whether you're using 2D shapes or 3D shapes, and have the same conversation within the classroom, and just enriching each student's knowledge based on whatever shapes those students chose to use when creating their creatures. So I challenge you today, or tonight, when you go with the teachers, to look for either open questions that the teachers are using in their lessons with you, or parallel tasks. These don't have to be used in every lesson, both of these. But Eric and I are having a hard time finding a Bridges session in any grade level that does not have an open question. Parallel tasks, they exist if you look for them, but open questions are in every single session. I encourage you that when you're working with your students at home, to ask questions, to not give answers, to not be that wealth of knowledge and yes, I know how to do it and here's how. Well, what do you think about that? Why do you think that way? How can you show me that this is the right way to do it? Prove that to me. Those are the types of questions that we use in the classroom and that we encourage you to use at home with your kids. If you don't know how to do it, sometimes just asking the right questions, they'll get it on their own. But it's just continuing to ask questions. Why? Well, I'm not sure about that. Let's try this. As opposed to saying, well, when I did it, I used to do it this way. And I don't know what your teacher's talking about. They're crazy because that's not how I learned it. And truly, I can say that as you learn and are more experienced with Bridges, with those home connections coming home or the homework that they're sending home with you, it looks really different than the way you learned. And that's a little bit scary as a parent who always wants to have all the answers for their kids. And I get that as a parent. But if you continue to ask questions or contact the teacher and say, hey, you know what, even through questioning, my child still isn't getting it, what can you suggest to me? What kinds of questions can I use with my child? Or what websites might I go where they show this same type of thing, and the Bridges website is great for that. You'll have much more success. You don't have to be afraid that you don't have all the answers, because that's not what it's about. So, with that being said, now's your time to write down any questions that you have that you didn't get answers to on the frequently asked question sheet so that we can look those over, and when you come back from your lesson, we will be able to answer any of those. We are now going to dismiss you. Why don't we start with kindergarten teachers. If you are going to observe